Good afternoon, my favorite stats class of 2017. This afternoon we are going to begin chapter 8, which is confidence intervals. These bad boys are not going away. They're something that we're going to spend a lot of time on as we finish out this semester in the spring. We're not actually going to work any problems over the next 2 days. We're just going to be talking about what a confidence interval is, what it tells us, how to interpret it, and how to use them to help make decisions as we go. So it's kind of where we're going, and that's where we're headed. So big picture is what is different from this chapter from the previous chapter that we just started. The biggest difference that you're going to notice is that in chapter 7, we were given mu and p. These were our parameters, okay? These are things that we were told the mean weight of whatever, the mean height, the mean length of a hot dog, yada, 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 the proportion, true proportion, whatever it looked like from there. The key difference here is that in chapter 8, now, these things are going to be unknown. We really don't have any idea what these things are, really ever. Okay, the fact that we gave them to you in chapter 7 was more to begin to build your foundation for what statistics is. But real statistics is chapter 8, and that's the fact that we don't really even know what these parameter values are. So that should be fun. I think we're basically saying the same thing here. If we already know the true parameter, then what sense does it take making samples? The big thing here again in chapter 8 is that those values are not going to be known to us. We were going to do an activity, but since I'm not here, it's kind of hard to talk about. So we'll just kind of keep rolling through there. Today's going to be very informational. The first thing, because you don't have enough vocab on your plate already, is we are going to define the term point estimator as a statistic that provides an estimate of a population parameter. Okay, so fancy name, another name for saying that X bar is a point estimate for the parameter mu. Basically what we're hoping by taking a sample is that sample tells us something about the whole piece of the pie. The same would be true for proportion. So this would be our means language. And then as always, there could be proportions. And in that case, we're hoping that we say that p hat is the point estimate of p. Point estimator is one of our best guesses for the value of the parameter when you're not really sure what it actually is. So again, we're taking that small slice and hopefully telling us that'll give us some information about what that mystery parameter happens to be. The distance from X bar to mu is the distance from X to, I don't know what I'm trying to say there. We are going to use this rule, so to kind of refresh you on what we saw here, 68.95, 99.7. It was a little bit on your review sheet for chapter 7, so let me just draw you a picture to help you refresh that rule in your mind. So here's your mean. So basically we're saying if you go 1 standard deviation to the right and 1 standard deviation to the left, that this will encompass 68% of all observations, or 68% of the distribution. Go 2 standard deviations, and we're going to say that this is 95% of the distribution, and then if you went a 3rd standard deviation, then you would end up at that this would be 99.7% of the distribution. So that would leave a little bit on the end of each tail that's unaccounted for. So that would be 0.015 and 0.015. Therefore, 95% of all samples will be within 2 standard deviations, basically the same rule that we just talked about. This is going to be important for us as we move forward. So this is just some background information. It should look familiar, and it should be something that isn't catching you too far off guard. All right, so now let's finally get to this thing that we're wanting to get to, a confidence interval. So it gives us, it's basically exactly what it says. It's an interval that gives us possible values for our parameter when we don't know exactly what it is. Okay. I will tell you that this is an extremely useful formula because we are going to use it all year over and over and over and over again. Okay. I'm trying to think. There's another name I use for point estimate because that's exactly what you need is another name. Right now, it's not coming to mind of what we call that, but it'll come to me here in a minute. So point estimate plus or minus margin of error. Basically, if you look at your curve, here's what we're going to do. Here's the true mean. We're going to take some value, let's say that x bar, and then we're going to build a distance. So this would be the plus side, this would be the minus side, and hopefully by creating this interval, somewhere along that interval, we will actually capture, yes, we're going to use capture the flag language, we will capture what that true mean really is. And in this case, if you look at this confidence interval that I just created, that's exactly what happened there. We were able to find that true mean. We have some actual values as kind of a starting point for where that value, that parameter value actually may be. So what is margin of error and how do we find the margin of error? So margin of error, a lot of times you'll see me abbreviate this, is simply a critical value times the standard deviation of your statistic. Now, I'm throwing a lot at you today. This is on your formula chart. Okay, and it's actually written in this exact same language. But your margin of error is no more than your critical value times the standard deviation of your statistic. So, and why do we include margin of error? We include it so that we increase the likelihood, likelihood is the word I want to go with, of capturing the true population parameter. Again, a lot of things, these are Uriisms as I call them. I like to call your margin of error as your wiggle room. Basically, by having that margin of error, you do not have to be exactly correct with what that point estimate is. Because let's be honest, the chance that your point estimate is going to exactly match the mean of this distribution here is 1 in a million. And those are pretty good odds. It's probably more like 1 in 10 million. So by building that point estimator, now you've just increased that chance that you're going to find that particular parameter value. All right, if you don't get anything else down today, this is something that needs to happen there. This is the interpretation that we are going to use for every single confidence interval that you ever create in this class or in future statistics classes. So it is a cookie cutter example. It works marvelously for this type of example. So we are C%. This would be your confidence level. Typically, this will be, let's say, 90% confidence interval. You could do a 95% confidence interval. You could do a 99% confidence interval. These are just some common ones. It is not uncommon. You could, for some reason, be asked to find an 86% confidence interval. It's not common practice. 90 and above is typically common. But it's not to say that you couldn't be asked to find an 86%. So that's beside, we'll keep going there. So we are C% confident that the interval from, this would be the left endpoint to the right endpoint, captures the actual value of, and then that's where our context is going to go. Okay, this is basically just going to be rephrased from our problem. So you'll kind of get the hang of it as we go here in just a second. So big ideas so far. What do we have? We have a point estimate. That's our x bar or p hat, depending on whether or not we're doing a confidence interval for means or proportions. That's just another way to say the exact same thing. We're going to use the 68, 95, 99.7 rule, although it has not come into play yet at this point. Going the wrong way. We're going to use this basic formula to construct every single confidence interval that we ever use. Our point estimate plus or minus our margin of error. What is the margin of error and why do we use it? Here's how we would actually calculate that thing. We could probably table that for today, but it's okay. I want to get you to start thinking about what it is. It's basically our wiggle room so that we don't have to be exactly correct with our sample. And then this is how we're going to actually interpret it. So we are 90% confident that the interval from blank to blank captures the actual value of the true mean of whatever it is that we're looking for. All right, here's what's a little bit different, and I will try to do my best on this video. It probably won't come out the most clear, but I can formalize it when I get back to class and you have a chance to ask some questions and I can get some feedback from you. So the confidence level C is the overall capture rate if the method is used so many times. So let me make a big difference here for you. When you are talking about one confidence interval, you are going to use the interpretation that we just talked about. We are blank % confident, yada, 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 yada. You were talking about one specific interval, and within that interval, you are 90% or whatever % confident. Now, before I make to this next interpretation, let me squish some bugs here. Confidence does not equal probability. Okay? When we talked about probability in the fall, probability had to do with millions upon millions upon millions of trials of the same thing. It was a long run situation. With a confidence interval, you have only collected one sample, done one set of calculations, and made one conclusion. That does not constitute probability. Okay? Confidence and probability are two totally different things. So just because there's percentages there, do not equate that to meaning probability, because it's not. It's totally different. So that being said, a confidence level deals with the process over and over and over. Okay? Basically, a confidence level is telling you that if you were to do this process that you use to find one confidence interval many, 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 many times, that using that process over and over again, about blank % of all intervals would capture the parameter. So again, you're talking about one interval versus lots and lots and lots of intervals. So that's kind of where we're going from there. Just 1 second. I had to collect my thoughts before I can move forward. All right. Again, here's kind of confidence levels. I will go back through this with you once I return, just because it is something that on paper it doesn't seem much different. The two don't seem different. In theory, they are completely 100% east from west, so they're very different in the way. This is a good interpretation if you need something to kind of tie together and hold you over till then. If we take many samples of the same size from this population, about 95% of them will result in an interval that captures the actual parameter value. Again, this is referring to the process of confidence intervals, not actually just calculating one. Okay? So that's kind of what confidence means here. Again, confidence does not equal probability. Two totally different schools of thought. So let's actually try some. What we got here? We got two examples. Perfect. So according to a Gallup poll published on January 9th, 2013, a 95% confidence interval for the true proportion of American adults. I'm going to highlight this because this is going to be very important for us, because this is who support the death penalty. So this highlighted portion is telling us who we're collecting information about. So in this survey, these people were asked to give their opinions on the death penalty. Okay, and the confidence interval turned out to be 63% plus or minus 4%. Okay, you've probably seen something like this on the news if you're exposed to any kind of social media news, TV news, wherever you get your news from. So the estimate was based on a random sample of 1,038 American adults. Interpret this interval in context. So they did a couple different things here for us. They gave us a confidence interval, but they didn't give us endpoints. So let me translate what's really going on here. So this 63% is their p-hat. Okay, we could also refer to this as their point estimate. Same exact thing. The only reason I use p-hats is because it is a proportion. Okay, and then they added the margin of error. Okay, so plus or minus margin of error or wiggle room is what they added on. So what they're saying here is if you were to continue building this particular interval out, is that they believe that the true proportion is somewhere between 59%, that would be 63 minus 4, and up to 67%. Okay? So they believe that the people who support the death penalty in America is somewhere in between these two values, 59 to 67. They're not real sure where, but at least they've narrowed it down from out of 100%. Now they've got an 8% span that they feel like that particular parameter is within. Now, this is all great. This is all dandy. It's kind of showing you how to do it, but unfortunately it doesn't answer the specific question that they asked in this problem. And that specific question is to interpret this confidence interval in context. So using our cookie cutter translator that we're going to use all year long, here's what it would look like. So we are, you could say I am, doesn't matter the verb tense. So we are 95% confident. This is important. You got to have your confidence level in there. That again, just take this straight from the problem. True proportion of American adults who support the death penalty. I can hear the eyes rolling as I'm recording here. I think it is a direct correlation to the amount of writing. That's okay, you'll get over it. Who support the death penalty is in the interval 59% to 67%. Now, the only really freedom that you have in this example here is because they gave you the confidence interval in the format that they did, you could represent it in that same exact format and get full credit. Okay, you didn't have to build it out like I did here. I think you're all more than capable of adding 4 and then subtracting 4. So either method here is acceptable. The things that aren't negotiable are your confidence level 1, your context 2, and then actually in some way, shape, or form, including your confidence interval. Okay, these 3 things are not negotiable. Okay, if you want to do we or I, that's negotiable. If you want to present it in a couple different ways for your confidence interval, that's negotiable. Meat is not negotiable. Okay, confidence level, translation, confidence level, context, and then the interval itself. That's kind of the star of the show, so it's got to be there somehow. So hopefully this kind of clears things up a little bit, and you're kind of beginning to scratch the surface. I know we're going slow. If you have a question, I'm sorry I'm not here. This is not a good day to miss because I love confidence intervals, 1, and 2, because I know there's questions that you're not getting answered. But if you need to lean over and ask a neighbor, say, hey, what's he talking about? That's fine. All right, let's try one more example and see if we can answer some of those questions just by practicing a little bit more. So a large company is concerned that many of its employees are in poor physical condition, which can relate to decreased or result in decreased productivity. To determine how many steps each employee takes per day on average, the company provides a pedometer to 50 randomly selected employees to use for one 24-hour period. So a lot of words there basically to tell us they sampled 50 people with these pedometers. After collecting the data, the company reports a 95% confidence interval of 4,047 steps to 8,473 steps. So, interpret this particular confidence level. So, here's what we're talking about with level. Level is talking about the process. Okay. So here's how we would do it. Actually, let's skip to part B because that's the part you still need practice at. And this is what we're going to talk about a lot more often than the actual level. So if we interpret the confidence interval, here's how we go. Cookie cutter example. We are 95% confident that I'm trying to look for my context here. We're looking for mean number of steps taken by an employee. So confident that the true mean number of steps for an employee is in the interval 4,547 to 8,473. Same exact interpretation as before. You guys are going to freaking dream this in your sleep by the time it's over. You will not. You can thank me later for that. Now let's talk about the process. So let's backtrack a little bit. What is the actual process here? So we're saying that if we were to repeat this process or to try another interval, we would still be 95% confident in that interval. And if we did it again, we would be 95% confident in the next interval. The level here is telling me that in repeated samples of 50 employees, the process would capture the true mean in about 95% of all constructed confidence intervals. I know it's writing intensive today, so I'll let you slip with a CI in there instead of a confidence interval spelled out. We're just going to kind of move on from there because, again, that's a really complex idea. We can, however, calculate the margin of error. Now, you're thinking to yourself, how is he on earth going to do this when the last example gave him the margin of error? This one gave him just 2 endpoints. Well, here's what I'll tell you to go back to drawing curves. Okay. So I know that the low number of steps was 4,547. I know that the high number of steps was 8,473. And I know that based on the formula that we have for confidence intervals, it is point estimate plus or minus margin of error. So I know, just like a normal curve, that this interval they created is symmetric. So I know that the mean has to be somewhere in the middle. But this distance and this distance are exactly the same. So let me call those Z just because we got a lot of X's already going. So let's find the total length of the overall interval, and let's just divide by 2. So 8,473 steps minus 4,547 steps tells me the length of that interval is 3,926, but we just want one margin of error. So divide by 2, and that would tell me that the margin of error for this particular interval is 1,963 steps, based on the fact that that interval is entirely symmetric. So that's what it, part of one of those things of just being a confidence interval. All right, two more questions to answer up. What is the point estimate that we use to create this interval? Well, we actually had to find that as well. We couldn't find it now that we know our curve. So I had, what was it, 45, 47. I knew that this was 8,473, and that the margin of error, based on my calculator still up here, was 1963. So you got a little freedom again. If you're an addition person, add to the lowest value. If you're a subtraction person, add to 8,000 or subtract from 8,000. Okay, but either way, it's going to put me back in the middle of this interval. So I'm an addition person, 4,547 steps plus 1,963 steps tells me that that point estimate happens to be 6,510 steps. Or we could have called this X bar, would probably be a better way to say it. Now, pedometers have kind of become all the rage of recent, especially for their, based on how many steps you take, the healthier you're going to be. Kind of the new number that everyone talks about is getting in 10,000 steps a day. So, is this company meeting that particular guideline? Well, go back to what we just talked about. Here's the interval as a coordinate point. Here's the interval on a number line. Where is 10,000? Well, it's going to be way over here to the right, and it's not really in our confidence interval. So would you be willing to say, based on the interval that you see here, that this company is reaching 10,000 steps a day? Well, absolutely not, because it's not inside the confidence interval. So, and the explanation is simply that, okay? 10,000 steps falls outside of the 95% CI, which draws the conclusion that this company is not meeting their steps. The company is not meeting the 10,000 step goal. Simply on the fact it's either in, this would be convincing evidence if it was somewhere in here, but the fact that it's way outside, not even close to being, by about 1,500 steps, tells you that these people need to get off their rears and start walking around a little bit more at work. Well, that is just the beginning of confidence intervals and the surface that we are going to scratch with them. This process will begin to get a little bit more in depth, but again, it's the theory behind of it that we're interested in today and getting the big idea of what a confidence interval actually is. Because I can teach anybody to punch buttons and follow a formula and do that kind of thing. If you actually know what you're doing, then you're a powerful statistician. So the homework's in your notes, and you should be ready to roll from there. So have a good afternoon, and I will talk to you later.